Hey, this is Mr. Aiden, and we're going to take what we've been doing with trigonometric equations and go to solving them finally. In section 5.3, solving trig equations, we're going to be using our algebra and our unit circle in order to solve these equations. So we're going to just show a bunch of examples today, and hopefully this helps out. And you need to have your unit circle around. That's going to help big time. So we're just going to do some algebra here. So you can see 2 sine of x minus 1. So what are we going to do? We're going to add 1 to both sides. So we have 2 sine of x is equal to 1. Then we're going to divide by 2. And so it says sine of x is equal to 1 over 2. So when we do arcsine of 1/2 to find out what x can equal, we're going to look at our unit circle. And obviously we could be 30 degrees or pi over 6. Okay. We could also be, there's also another value right here of 5 pi over 6, isn't it? Okay. So we can be not only pi over 6, but we can also be 5 pi over 6. Now, keep in mind, it's not just we can be pi over 6 or 30 degrees, but if you add 360 degrees, you're back at the same exact point. So you can see how we could be pi over 6 plus any number of 2 pi. Any number of 2 pi. So, and we could be 5 pi over 6 plus any number of 2 pi. So you can see how we could be right here at 150 degrees, and you add 2 pi to it, you're back at the same angle. You add 2 pi to it, you're back at the same angle. Add 2 pi to it. You can keep going on and on and on and on. In class, guys, we're going to mainly just find the 2 or the 1 or 2 angles from 0 to 2 pi. Okay, we're going to kind of give it a stipulation, but just keep in mind, it could go on forever and ever and ever, because what do we know about these functions is these are oscillating, which means we can be 1/2 at a bunch of different points throughout eternity. Okay, so example 2 is combining like terms. So you can see how here we have our sine of x plus root 2 equals negative sine of x. So we're going to add sine of x to both sides, which means we're left with 2 sine of x. We're going to subtract this root 2 over here, so obviously moving the root 2 to the right side. Then we're going to divide by 2, so sine of x equals negative root 2 over 2. Now we can look on our unit circle. When is sine of x going to be negative root 2 over 2? Well, it could be right here at 5 pi over 4. It could also be right here at 7 pi over 4. And just keep in mind, if you wanted to find every single angle for that, you could add n times 2 pi. N times 2 pi, you had n times 2 pi, and that gives you every single angle. We're really just going to look for these 2 angles, though, in class, of what are the 2 angles from 0 to 2 pi. We can also extract square roots. So what's the first thing we're going to do? We're going to add our negative 1 over the other side. We get 1. We're going to divide by 3. So we got tangent squared of x equals 1/3. Then you're going to square root both sides to get the square out of there. So we're going to be the square root of 1/3, which is 1 over root 3, which is the same if you rationalize it as root 3 over 3. Now keep in mind, we're trying to find out where is tangent going to be equal to positive root 3 over 3. And so we need to take a look at that. Is x is going to be equal to root 3 over 3, right here at 30 degrees. We could also be across from that, right here at 210 degrees. And so we have 2 different angles that we could be at 30 degrees or pi over 6 and 210 degrees, which is 5 pi over 6. Okay, so those 2 angles, or sorry, 7 pi over 6 there, for those 2 angles for where tangent can be the square root of 3 over 3. Okay, let's go to example 4. Example 4, we're going to do some factoring here. Okay, so we have cotangent of x times cosine squared of x equals 2 cotangent of x. Okay, And so we're going to subtract. We're going to have cotangent of x, cosine squared of x minus 2 cotangent of x equals 0. We're going to factor out a cotangent of x. So cotangent of x equals cosine squared of x minus 2. Sorry about that. Equals 0. Okay, so we have two different places here. We know that to solve this, cotangent of x can equal 0. We also know cosine squared of x minus 2, sorry, that is a 2 right there, because when we factored out, is equal to 0, So we have two possible answers here, because we know when we factored out that this can be equal to 0. Okay, so this one is basically saying 1 over tangent of x is equal to 0. Okay, so when is 1 over tangent of x equal to 0? Well, let's take a look. We know tangent of x is equal to 0 at 0, and tangent of x is equal to 0 at 180 degrees. But where does 1 over tangent of x equal 0? Where does the reciprocal of tangent of x equal 0? Now, keep in mind, you can kind of do the reciprocal here. Tangent of x equals 1 over 0. Or where does tangent become undefined? And it becomes undefined at pi over 2, and it also becomes undefined at 3 pi over 2, doesn't it? At these vertical points right here. Where is the slope undefined? At these vertical points. Okay, so we have each one of these functions here in the each one of these solutions we could have. Now let's take a look at this other solution here. Cosine squared of x equals 2. I'll move the 2 over to the other side. I'm going to square root cosine of x equals the square root of 2. And the square root of 2 is 1.41, right? 1.41, so on and so forth. X cannot be any value greater than 1, can it? Okay, so this side doesn't work, does it? This side does not work. It's undefined, which means we're left with only these two solutions of pi over 2 and 3 pi over 2 that will work for this example. Let's go to example 5. Example 5, factor an equation that looks like a quadratic. Okay, now again, we've been doing this for a while. Substitute sign, we're going to substitute x for that. Minus x minus 1 equals 0. So we're going to have 2x times x, and we're going to have minus 1 and plus 1. Okay, because that gives us this factor right here, which means we're going to substitute the sign for the x right here. 2 sine of x plus 1 equals sine of x minus 1. That's the factoring of this. It equals 0. We have two different ways to do this. We know 2 sine of x plus 1 could equal 0. We know sine of x minus 1 could equal 0. And so we're going to subtract. So sine of x is equal to, we move the 1 over, that's negative 1. We divide by 2, negative 1/2. Sine of x could also equal 1. Okay, so let's take a look. Where does sine of x equals negative 1/2? Well, it equals negative 1/2 right here. It equals negative 1/2 right here. So we could be 7 pi over 6. We could be 11 pi over 6. Where does sine of x equal 1? Right here at pi over 2. So we have we have actually 3 different values that work. We have 7 pi over 6, 11 pi over 6, and pi over 2 that could work in this quadratic type. Now, you always want to check those back in the quadratic, see if they actually work. They actually do all of those work. So let's go to example 6. Example 6, rewriting with a single trig function. Okay, you can see we have sine squared of x, we have cosine of x. This is poop in a bucket, isn't it? Because we have different functions here. So what do we want to do with this sine squared of x? We want to change him into 1 minus cosine squared of x. We want to use the Pythagorean identity. Okay, minus 3 cosine of x minus 3 equals 0. Okay, let's do a little distributing here. So we have 2 minus 2 cosine squared of x minus 3 cosine of x minus 3 is equal to 0. Which means I really just have a quadratic type. Okay, now I hate quadratic types that start with a negative, which means that I'm going to move everything over to the other side in just a second. So, and it's just a preference. You could factor it out. So we have 2 minus 3, that's minus 1 equals 0. Now I don't like having this initial value be negative, so I'm going to move everything over the other side if that's okay. So I have 2 cosine squared of x plus 3 cosine of x plus 1. It makes everything positive, which is nice in life if everything is positive. So we're going to factor 2 cosine of x times cosine of x. That equals 2 cosine squared of x. What's my factors of 1 is plus 1, and that's all equal to 0. And you can see I have two different functions here. Okay, I'm saying where does cosine of x equal, I'm going to move the 1 over to the other side, negative 1 half. Okay, and where does cosine of x equal negative 1? And I'm going to look on my unit circle. Where does cosine of x equal negative 1 half? Well, that's right here at 2 pi over 3. Okay, so 2 pi over 3 works. It also equals negative 1 half right here at 4 pi over 3. Where does it equal negative 1? Right here at pi. So I have 3 different values that could work for solving this function. Basically, we're doing algebra. Once we do our algebra, we're looking at our unit circle. What can x equal? What can x equal? Let's take a look at squaring and converting to a quadratic type. Now, this one is a little bit more complicated. This one might be very difficult to see of how we're doing this. We have cosine of x plus 1. Cosine of x plus 1. So what we're going to do is we're going to square both sides. So I'm going to square this bad boy. I'm going to square this bad boy. So what do we have here? We have cosine squared of x plus 2 cosine of x plus 1. I foiled, ultimately. Don't forget, there's that middle term when we FOIL. Equals sine squared of x. Sine squared of x. Okay? And so that's kind of what I have so far. Now, you can see now the reason I squared it was sine squared of x is really nice because I have that Pythagorean identity. I know sine squared of x is 1 minus cosine squared of x, which means you can see if I subtract 1, that cancels him out. I add cosine squared. I have 2 cosine squared of x plus 2 cosine of x. The 1's cancel out. It equals 0. Okay. I can factor out a cosine now. Actually, I can factor out 2 cosine now, which means I'm left with cosine of x plus 1 is equal to 0. And now you can see what am I left with? I'm left with two things. 2 cosine of x is equal to 0, and cosine of x plus 1 is equal to 0, which means where does cosine of x equal 0? That's where does cosine equal 0? It's pi over 2 and 3 pi over 2. So I have pi over 2, I have 3 pi over 2. And then where this one says where does cosine of x equal negative 1? Well, that's at pi. So my 3 solutions for this is pi over 2, 3 pi over 2, and pi. And those all work. Okay. And so I want to, when I take each of these values, you want to plug it in the original function. Okay. Again, we could have an extraneous solution. And if you do that at home, you'll see pi over 2 works. You can see pi works, but 3 pi over 2 does not work, which means it is extraneous. It's an extraneous solution. So you always want to double check to see if your values work. I think I have one more problem here. And you're like, no, Mr. Aiden, you have a lot of problems. So we have 2 cosine of 3t equals 1. We're going to divide cosine of 3t equals 1 half. Delete that out. So I have cosine of 3t equals 1 half. Now, this is kind of weird. We've never kind of dealt with this where we have a multiple angle here. But I can know cosine of what value is equal to 1 half. So look at my unit circle. Cosine is equal to 1 half right here at pi over 3. I'm going to call that 60 degrees, or pi over 3. Cosine is also equal to 1 half right here at 300 degrees, or 5 pi over 3. Which means, let's think about this logically. This 3t, 3 times some angle, is equal to 60 degrees. Or 3 times some angle is equal to 300 degrees. Which means this t value is going to be equal to either 20 degrees, or this t value is going to be equal to 100 degrees. Okay? If you put that into radians, you could say 3t is equal to pi over 3, which means t would be equal to pi over 9. 3t equals 5 pi over 3, which means t is equal to 5 pi over 9. It could be either one of these functions. So if you have a multiple angle, something that's sitting right here next to the cosine, just use your unit circle to find out what angles it is, and then you can figure out what this variable is of t. So that is probably the hardest section, which is using your algebra, solving trigonometric equations. We're going to get a lot of practice in class. This is section 5.3. See ya, see ya, see ya.